Hey guys, welcome back. This is going to be a continuation of the Algebra 1 video on solving linear equations. So you'll see a part 1 and then this will be the part 2 to that. In the last video I talked about order of operations and I also talked about some just basic arithmetic concepts, and then we solved two linear equations. Here we're going to solve two more linear equations. And what I want to focus on in this video is the collection of like terms. Okay, so keep that in mind as we go through this. So we're going to be tasked with, let's say, solving for x. And then we'll be given this equation. Now this is an equation because it has an equal sign. So keep that in mind throughout your entire study of mathematics. It's important that this is an equation because there is an equal sign. And really what it's doing is it's just relating these two things. It's just saying that this one is the same thing as this one. But what we really want, our end goal here, is to get x on one side and have it equal some number, right? And it's, in this case, it's going to be some number that is within the real number set. And I'll make a video about integers and number sets in the future. But right now, let's just focus on getting all of the like terms on one side and then getting all of the other ones on another side. And so let's think about this. What terms in this equation are alike? Well, it looks like we have a term here with an x attached to it and also a term here with an x attached to it. So let's combine those first. And so how I'm going to do that is I will move all of the x's to the left side and then all of the other numbers to the right side. And I do that since we have a positive 3x. To make it go away, I just subtract 3x to get 0. And then we still have a plus 11 over here. Whatever I do to one side, I have to do to the other side. So I subtracted 3x over here. I'm going to do the same thing on the left side of the equal sign. When I do that, I'll get 2x, right? 5x minus 3x equals 2x. And then I leave the 7 alone for now. I bring down my equal sign, and everything else is accounted for. Let's simplify this expression a little bit. I can say 2x minus 7 equals, what's 0 plus 11? It's just 11. Now, here is an important step. I need to get the x term by itself. So that means I need to get 2x by itself right now. And how I can do that, since I have a minus 7, to undo this on the left side of the equation and compensate for that on the right side of the equation, I just add 7 to both sides. Okay, so now we have 18. Bring down the equal sign. This turned into 0, right? Negative 7 plus 7 equals 0. We bring down our minus sign, bring down our 2x. I'm going to rewrite this, simplifying it. What's 2x minus 0? We can just drop the 0 and then bring down our equal sign in 18. All right, so now we have multiplication here, right? Multiplication by adjacency. When two of these characters are adjacent to each other or next to each other, it means multiplication. How do we undo multiplication? Division. What are we dividing by? Do we divide by x or do we divide by 2? What's going to get x by itself? Well, if we divide by x on both sides, the x cancels out, and then we get 2 equals 18 over x, and we still don't have x by itself. So that is not the correct route to go. Our only other option is to divide by 2. This cancels out, and whatever we do to one side, we do to the other side. Now I'm going to rewrite the expression once more, but now we have x by itself equals, what's 18 divided by 2? If you don't know this by heart, you can always just count by 2 and tally the number of 2's that are in 18, right? So we're going to go 2, 4, 6, 8, 10, 12, 14, 16, 18. This right here is 5, and this is 4 tallies. 5 plus 4 equals 9. X equals 9. Okay, and one more just to solidify everything. Again, we're going to solve for x. But now we're going to make use of a property that we haven't talked much about. And some of you may be seeing this and already know. So I want you to keep in mind throughout this process that a times b plus c, where a, b, and c are some real numbers, we can make use of the distributive property and say that this is a times b plus a times c. All I did there was I did a times b plus a times c. A times b plus a times c. A times b plus a times c, right? That is the distributive property. Excellent. So keeping that in mind, we kind of have something similar here, right? We have like an a, and then we have like a b minus c, right? So let's apply this rule to our equation, and we can do it on both sides since we kind of have the same situation here, right? We have this one and then we have this one. They look like they have the same structure. Okay? So what we're going to do before we start solving is we're going to expand, or we're going to distribute this 4 into this parentheses, and we'll distribute the 3 into this one. So let's just get moving here. That will leave us with 8x minus 12. Don't forget the minus 5 equals 3x plus 3. Don't forget the plus 8. Let's simplify more by just combining like terms here on each side of the equation. So we have 8x. What's negative 12 minus 5? That's minus 17, right? This equals 3x plus 3 plus 8. What's 3 plus 8? That's 11, right? Cool. So now we have something similar to where we started at last time in the first example. Combine all the like terms. Let's just keep the same convention, and let's move all of the x terms to the left-hand side and all of the other constant terms to the right-hand side. To do this, I have a positive 3x. I'm going to subtract 3x to get 0 plus 11 on the right-hand side. Bring down the equal sign. And I have 17. But remember, whatever I do over here, I have to do right here as well. And 8x minus 3x is 5x. What's 0 plus 11? It's 11. Bring down your equal sign. 5x plus 17. All right, now we need to get this term by itself, right? So how do we do that? We've got a plus 17 on the left side. Let's subtract 17 to undo the addition to get 0 there. Bring down the 11. Also bring down the 5x. What's 5x plus 0? It's just 5x. That equals 11. How do we undo this multiplication? We divide by the constant that it's being multiplied by on both sides of the equation. We have to do that. Whatever we do to one side, we've got to do to the other side. This leaves us with this cancellation, and x equals 11 fifths. And if you are to put this in decimal form, you end up getting 2.2. And so if we're to plug this value of x, 11 fifths or 2.2, into this equation, and really our starting equation, this would be a true statement. This would be equal to this. So that's going to wrap up this video on solving linear equations. I think I probably will not do another video on this unless somebody requests it. If you need me to clarify anything, leave it in the comments. And if you would like me to cover anything in the future, also leave that in the comments. I would be happy to oblige with that. That will wrap up this video. Have a wonderful day.